Okay, folks, we are back, and I want to take a look. There were two last problems in section 3.1 that we worked in class today, and so I want to go through, give you a nice clean version of it. So let's tackle problem 20. Problem 20 says, prove that 4 divides the quantity 13 to the nth power minus 1, and that holds for all natural number n. So if we're going to prove this, I think that I am doing most likely a proof by induction, starting with the first natural number. So I would say something to the effect, note that 13 to the first power minus 1 is 13 minus 1, which is 12. And 4 does divide 12. So the initial step holds. Okay. Now let's set this up for a general natural number k. So 4 divides the quantity 13 to the k minus 1 for some k out there that is a natural number, or integer 1 and bigger, right? Okay. Now we have to discuss what this means to us. Thus, then there exists some integer. What's your favorite integer? I don't know. T. Such that 13 to the k minus 1 is 4 times this t. Okay? Now what I'd like to do is take a look at 13 to the k plus 1 and show that because we've assumed this, we can then assume that. So now consider 13 to the k plus 1 minus 1. So I'm going to actually put this over here. 13 to the k plus 1 quantity minus 1. Well, we want to go back and use this business here, right? So let me peel out a 13. This is 13 times 13 to the k minus 1. Now, I've got to be a little careful on this because I don't technically have this yet, right? I have some of the pieces. The kind of crucial piece of this, though, I think, is the fact that 13 is really 12. I'm sorry. Yeah, 12 plus 1. Okay? All right. So I'm going to use that fact, 12 plus 1 times this 13k business, okay, minus the 1. And now, let's see, this is now, I've got, distribute this through the parentheses, so I've got 12 times 13 to the k, which is nice. That's actually divisible by 4, right? And then I've got 1 plus 1 times 13 to the k, and then minus the 1. Well, we know something about 13 to the k minus 1. That's part of our assumption. This is now 12 times 13 to the k, and this is 4 times some integer. Okay? And so perhaps the last change we need in our string of equations is just simply to factor out a 4, leaving me with 3 times 13 to the k plus t. Okay. So I think we got it. That's going to tell me then that this divides that. Thus, 4 divides 13 to the k plus 1 minus 1, and then the inductive step holds. So one last sentence, therefore. The statement holds for natural number n, and I typically mention induction in here, by induction. Okay, and put middle square. Alright, give you a sec to look that over. Actually not a bad bad result, not bad at all. Okay, nice use of induction there. Okay, all right. Let's move on then to problem 21. This was the other one that we did, which asks us to prove that 6 divides 7 to the n minus 1 quantity for all natural number n. Okay, I think you're going to find it's a very, very similar proof. It all kind of comes down to 7 being 6 plus 1 in the grand scheme of things. So again, I would start with n equal 1 and then go on and prove this by the use of induction. So here's the way I would do my proof. Note that uh, 7 to the 1 minus 7 is 6, and 6 divides 6. So the basis step or initial step holds. Okay. Now assume that this holds for some natural number k. Okay. And what I would like to, well, let's talk about what that means. Then there exists, you want to use t again? T, that is, technically it'd be a natural number, but that's fine. Such that this 7k minus 1 is equal to 6t. Now what we want to look at is 7 to the k plus 1 minus 1. Alright, so let me put that over here. 7 to k plus 1 quantity minus 1 equals. And again, I'm trying to access my information here about 7 to the k, so let me peel that 7, peel a 7 out of here. Okay. Minus 1. Now notice I don't really have yet 7k minus 1 anywhere in this. I've got 7k there, but it's not an entire piece that I can remove because this piece of it is being multiplied by 7. This part is not. So, okay. However, I can draw upon the fact that 7 is 6 plus 1. And when I distribute this through the parentheses, I get 6 times 7 to the k plus 7 to the k minus 1. And there you go. There's the 7k minus 1. I know that that is 6t. So this is 6 times 7 to the k, and then this part right here is 6t. And as one last step, I might want to factor that 6 out. And that's it. So since 7k plus t is an integer, then 6 divides 7 to the k plus 1 quantity minus 1 quantity. And the inductive step holds. Therefore, I'll even put it in this time. By induction, the statement holds for natural number n. The box. Okay? So that is the end of our problems in section 3.1. I'll be back shortly and we will take a look at the problems we worked out of 3.4. All right. Let me know if I can help you with anything, and I'll see you in a few minutes.